let's do some calculations with atomic theory here. Now, if you're reading through your textbook, they're going to go through a lot more equations. There's all kinds of different equations, and some of them are really awesome. But they've scaled this down quite a bit in the new AP curriculum. So there's really only 2 equations that you have to worry about. So if you are reading through the textbook, don't worry about anything besides the 2 equations that we go through in this lecture guide and the 2 equations that are in your AP packet. Here's one of them. This frequency times wavelength equals speed of light. Here's how you may be using that equation, which again is given to you in the packet, and they'll tell you what all those symbols represent. We've got red color seen in fireworks due to emissions of light with wavelengths around, oh, here it is, 650 nanometers when strontium salts are heated. And you may remember doing this in first year chem, where you're looking at all the different colors of light that are formed when you heat different ionic salts in the lab. And I think then there's an unknown, and you're supposed to figure out what the unknown metal is to blast. We'll do some of that here too, all that flame testing, because it's fun and it is kind of interesting. We want to calculate the frequency of this red light. Okay, so I've got my equation. Frequency times wavelength equals the speed of light. And now we start plugging and chugging, but here's the problem. When I look at the AP packet, I have the speed of light given to me, c. Speed of light is 2.998 times 10 to the 8th meters per second. Here's how it's listed in the packet. Here's our problem. That's meters per second. This one's in nanometers. Tricky. So we're going to have to make a switch. We either have to switch them both to nanometers or both to meters. Probably easier just to go both meters, right? So we're going to take this 650 nanometers, and then we'll just set up a proportion. Now, unfortunately, this is not given to you in the AP packet, so we will want to know the switch between meters and nanometers. And again, you could set this up either way. You could say that 1 nanometer is 10 to the negative 9th meters. Or you could do this. You could say 10 to the positive 9th nanometers. Make up 1 meter. Either way, you're going to get the same answer. Okay, so let's plug this in. Now it's not such a big deal, but that's the one thing that you got to keep your eyes open for. I mean, for the most part, this is just algebra plug and chug. We want to solve for the frequency. So we've got frequency, and then we do have the wavelength. And this is going to end up being, now I'm going to just leave this as 6.5 times 10 to the negative 7th meters. Only because there's no decimal spot at the end of that 650. So I'm going to assume that that was maybe rounded, and just the 6 and the 5 are significant. Now I can plug this in our calculator and solve for the frequency piece of cake. 4.6 times 10 to the 14th. And again, for unit, meters and meters are going to cancel. So your unit really is like 1 over seconds. You could say seconds to the negative first. You could say SEC to the negative first. 1 over SEC seconds. We get it. Those would all be equivalent. Well, gosh, that's easy. 99% of people that get that wrong, get it wrong because they missed the unit conversion. You got to keep your eyes open for that nanometer. Little stinker. Here's another one. What's the wavelength of electromagnetic radiation having a frequency of 5.00 times 10 to the 12th second to the negative 1 cycles per second? And then we want to know what kind of electromagnetic radiation this might be. Well, that sounds exciting. So again, we've got our equation. Frequency times wavelength equals the speed of light. And it's just plug and chug from here, right? So we've got our frequency this time with 3 significant figures. So I'm going to leave that 5.00 times 10 to the 12. Seconds to the negative 1, s to the negative 1. Cycles per second. We get it. This time we're solving for the wavelength. And the speed of light in the packet, 2.998 times 10 to the 8th meters per second. Awesome. So all we have to do is plug this in our calculator. We're solving for the wavelength. And now I just have to be aware that my unit will come out as meters, right? So I've got seconds and I've got seconds. They're going to cancel. This time, let's go. Oh gosh. Should we go like 3 sig figs? I mean, it's right smack around like 6.00 times 10 to the negative 5th. Now that's going to end up in meters. Okay, so this last part, so far this is really easy, right? What kind of electromagnetic radiation is this? Well, you might remember this guy, the electromagnetic spectrum, which gives us a listing of different kinds of energy, from high energy to low energy, starting with the gamma rays, the X-rays, the ultraviolet, which means above violet. So then I've got the visible light spectrum, starting with violet, going down to the red light. And then we've got infrared, which means below red, microwaves down to radio waves. And so again, like at the end here, we've got giant waves. Look at those wavelengths, wavelength in meters. So we're looking at like 1 meter all the way up to 10 to the 4th meters when we're looking at radio waves. Gamma rays are like 10 to the negative 12th. So those are super small wavelengths, which means high frequency and then high energy. So what they may do on an AP question is give you some chart that lists this information. You don't have to memorize the different wavelengths of, ultraviolet and microwaves and all that. That'd be crazy. But if they gave you a chart, we might be able to kind of match up what type of radiation is emitted based on calculating the wavelength. So here we were looking at about like 6 times 10 to the negative 5th. So if we're somewhere in the negative 5th ballpark, we're probably somewhere in here. I think we're safe calling it infrared, huh? So let's do that. Let's call it infrared radiation, and then we are good to go. There, this equation is super easy to use. Everything that you'd ever need is given to you in the AP packet, except for the switch between meters and nanometers.